हेलो माय नेम इज़ दिवाकर सनकरी। वेलकम टू माय यूट्यूब चैनल मैथ एक्सप्लोरर। आज मैं डिस्कस करने वाला हूँ बाइनरी ऑपरेशंस। तो व्हाट इज द बाइनरी ऑपरेशंस? लेट S be a non-empty set. A binary operation on S is a functions from S Cartesian product x into S. यूजुअली हम लोग फंक्शंस को डिनोट करते एफ जी एच इट कोई एक सिंबल देके, बट यहाँ पर हम लोग फंक्शन को डिनोट कर रहे हैं प्लस माइनस स्टार एंड एडिशन अंडर सर्किल इट इज कोई भी सिंबल से यूज कर सकते हैं। कोई भी एक फंक्शन एफ ए टू बी, इसको वेल डिफाइन कब बोल सकता हूँ? जब कोई भी एक एलिमेंट डोमेन सेट से लूंगा x belongs to a and f of x belongs to b, that is f of x एग्जिस्ट कर रहा है, देन इसको वेल डिफाइंड बोल सकते हैं और मैथमेटिकल सिस्टम बोल सकते हैं। हेयर सेम केस। अच्छा, कोडोमेन डोमेन सेट से कोई भी एक एलिमेंट x को y, उसके ऊपर बाइनरी ऑपरेशन स्टार अगर अप्लाई करेंगे तो अगर वो इस सेट के अंदर रहेगा तो वो मैथमेटिकल सिस्टम होगा एंड इस सेट को हम लोग क्लोज्ड अंडर स्टार बोलेंगे। कुछ कुछ ऑथर इसको ग्रुपाइड बोलते हैं। On the set, for example, on the set Z star stand the binary operation additions 2 star 4 equal to 6. That's mean 2 plus 4 equal to 6 यार स्टार को हम लोग additions consider कर रहे हैं। Similarly for the set n यार we consider the binary composition addition. But natural number is not closed under subtractions because 2 minus 3 equal to minus 1, but 2 and 3 are natural number, but minus 1 is not a natural number. When I called a star is commutative and associative. A star is commutative if A star B equal to B star A, and A star is associative if A star B A star C equal to A star B star C. For all ABC belongs to X. Then what is the definitions of identity element? In the mathematical system G star, an element E belongs to G is said to be identity if for every element of x belongs to G, x star E equal to E star x equal to x. And for example, in the mathematical system Z dot, the identity element is 1 because 1 into x equal to x into 1 equal to x for all x belongs to Z. And for M to R mean 2 cross 2 matrix over real number. Under multiplications, the identity element is I2 because I2 in I2 mean 2 cross 2 आइडेंटिटी मैट्रिक्स। I2 के साथ अगर कोई भी मैट्रिक्स को मल्टीप्लाई करे तो वही मैट्रिक्स निकल के आएगा। एग्जाम्पल 3, अगर A इक्वल टू ई ए बी एक मेंबर का सेट है, अगर ए स्टार डिफाइन करे ए कैली टेबल के अंदर, हियर वी नोटिस दैट ई स्टार ई इक्वल टू ई स्टार ई इक्वल टू ई, मतलब यहाँ पर ई के लिए ई ही दे रहा है, ई के साथ कंपोज करने पर ई स्टार ए इक्वल टू ए स्टार ई इक्वल टू ए। Similarly, E star B equal to B star E equal to B. From the table, we notice that this happen. So, from the table, we say that E is the identity element because E star X equal to X star E equal to X for all X belongs to A. By definitions of identity element, it is E. I say E is identity element. An identity element of a mathematical system G star, if it exists, always it cannot be exist. If it exists, it is unique. For this question, we consider two identity elements. Then we arrive contradictions and we conclude that the identity element is unique. The first I consider two identity element E and F. Then E star A equal to A star E equal to A by definitions of identity element. and since E is identity element. Similarly, by definitions of identity element, since F is identity element, so F star A equal to A star F equal to F for all A in G. We have E star F equal to F by the property of E, because F is an element of G, F identity element of G, as well as F is an element of G. So yeah, E star F equal to F because E is an identity element. Similarly, E star F equal to E because F is an identity element. So E star F equal to F, E star F equal to E. Therefore, E equal to F. Semigroup. What is the definitions of semigroup? A mathematical system G star is said to be semigroup if A star is associative. What is the conditions of associative? We discuss in first base. And for example, Z plus N plus Q plus Z dot N dot Q dot all are semigroups. And what is the monoid? Definitions of a semigroup G star containing the identity element is said to be monoid. That's mean in particular I can say a mathematical system is said to be monoid if A star is associative and G contain the identity element. Then the mathematical system G star is said to be monoid. For example, Z plus Q plus are commutative monoid, 0 being the identity element. Similarly, example 2, 3. Cauchy group. What is the definition of Cauchy group? A mathematical system G star is said to be Cauchy group if for any two elements A, B in G, for any two elements, each of the equations A star x equal to B and Y star A equal to B has a unique solutions in G. For example, Z plus is a Cauchy group because कोई भी दो एलिमेंट अगर कंसीडर करें A and B belongs to Z, then A star x, that's mean A plus x, here A star is additions, A plus x equal to B has a unique solution. What is the unique solution? X equal to B minus A belongs to Z. Similarly, and second equation, Y star A equal to B, Y star A equal to B mean Y plus A equal to B has a unique solution. What is the solution? Y equal to B minus A belongs to Z. And both the equations, we see that both the equations have unique solutions in Z. So I can say it is Cauchy group. Clear? Similarly, example 2, Z under multiplications is not Cauchy group because if I consider two elements 4 and 5 belongs to Z, then the equations 5 into x equal to 4 has no solution in Z. In the Cauchy group, it is say for all, it is true for all element, but which here we notice that there are two elements which does not satisfy the conditions of Cauchy group. So I can say it is not a Cauchy group. So next page. So we discuss some important result. Define a binary compositions star on the set Z by x star y equal to x plus y বিয়োগ x into y for all x in y in Z. Show that Z star is a semigroup. So for semigroup, first we show that it is closed and second it is associative. A star is associative. So it is closed, it is obvious because x plus y in sum of two integer it is also integer, and multiplications of two integer it is also integer, and subtractions of two integer also a integer. So it is closed obviously. What we want to show, a star is associative. So we start from the left hand side. X star y star z equal to x star y mean x plus y minus x into y. A star Z. Now it is A and it is B. We apply again the binary operations, and then I can write x plus y minus x into y plus z বিয়োগ and বিয়োগ এইটা into z, and continue this process. We obtain x plus y plus z minus x into y minus x into z minus y into z plus x into y into z. Similarly, if I write the right hand side and whose form is same as the left hand side, so I conclude that they are equal and Z star is a semigroup. Clear? Example 2. It is a important question. Let P of S mean the power set of S be the power set of S. Define a binary operation S star on P of S by S star S equal to A intersections B for all AB belongs to P of S. Show that P of S S star is a semigroup with an identity element. With an identity element, that means indirectly it is asked it is a monoid. So first property closure. Let AB belongs to P of X. Then A star B equal to A intersections B, and intersections of two set is the subset of S, and therefore it is belongs to P of S. Associativity, A, B, C belongs to P of X, and similarly we start from the left hand side. Then A intersections B intersections C, it is I can write A intersections B intersections C equal to A star B star C. So A star is also associative. It is so easy. And identity element. Here the identity element S set itself, because S star S equal to A intersection S equal to A itself. कोई भी सबसेट S का कोई भी सबसेट के साथ S का इंटरसेक्शन ऑलवेज वही सेट मिलता है, A सेट ही मिलेगा. Similarly, it is a left identity and right identity, so it is identity element. Conclusions: A star is closed and associative and has an identity element, so it is a semigroup with identity, or I can say it is monoid. Clear? Any doubt? Please, any doubt you can say in comment box.